Now we will be switching to the second part of the delineation. This is open source GIS in interactive delineation of a catchment, the basic ground units of hydrological studies. It may be known that a catchment of a point on ground is an upslope area which directs received water on its surface to the concerned point. Intending to this process, a part may go percolated down the surface, hold over upstream ponds, and a part may evaporate. In the field of hydrology, catchments are the basic units for carrying out surface runoffs and channelized runoffs pass through the points. This study facilitates in drawing hydrographs. The nature of the hydrograph curves characterize the hydrological behavior of the foundation. Are they porous, soaking, non-porous, or is it aquifer, aquitard, or aquifuse, etc. This provides the basis to assess what part of a total precipitation is converted into surface runoff and thus what part is percolated down to enrich the groundwater. The study provides crucial data for irrigation projects, reservoir and dam projects, development of a canal, etc. Thus, delineation of a catchment becomes very important. This delineation exercise is carried out in Saga GIS. The slide depicts the major steps in process of delineation. We need to have a DEM, if not a digital terrain model, is available to us. Suppose we have a sheet of plastic which represents the curvaceous surface similar to our area of interest. This sheet has holes here and there. If we pour water, the holes will drain the water and do not allow to flow into the downstream valley. Same in the picture with the DEM or DTM. In capture process from a satellite station, sensors could not record received signals of a unit area, resulting holes or a basin to hold free flow of water from top of the slope to outlets on periphery of the area. If such features are there with the DEM or DTM, the mathematical model in tracing the flow path get struck and could not trace the flow lines, flow accumulation, and so the catchments. Thus, we need to fill such holes or basins to facilitate the algorithm to reach the objective. Cartodem for 65 degree sheet. Araku is located within this sheet is downloaded from a Bhuvan website of a National Remote Sensing Center. Access to download page is login based. So create your own account and download an imagery of your area of study. Pre-process the DEM for its projection, optimization of a resolution of a work, data type, download, make the imagery available in geographic coordinate systems. But we carry out our project work to obtain length, width, aerial assessment, reserve calculation based on real metric values, not in a longitude or latitudes. It is always advised to proceed with projections of imageries and rasters. In process of projecting the imageries, think of a resolution and a data type you will handle for your project. High resolution with a double type data at a pixel is chosen for detailed work, and low resolution and float or integer type is chosen for rapid processing of the tools to result into output or outputs We have carried out our study on WGS 84 UTM 44 zone with the 75 meter into 75 meter resolution and integer data types at pixels of the imagery. As stated, the DEM is subjected to fill basin operation to obtain desired results. We have carried out this operation with the Saga GIS. Menu path to tool for fill basin is shown in the slide. We preferred the Wang and Liu method of a basin fill. Basically, basin fills are focal functions where a small window, say 3 by 3 or 5 by 5 or such an array, scans the raster or imagery and reassign new value to fill such holes. The output of the basin fill operation appear in the tree view panel. Double click the layer and get a view of the raster in a display device of the GIS. Right panel is populated with information on the raster and behaviors such as color representation to be managed by the user. We carried out flow accumulation operation on filled basin DEM. Conceptually, liquid like that of water has a tendency to flow down slope. This concept is utilized in an algorithm of flow accumulation. In a reiterative manner, the algorithm go on counting the number of pixels feeding to the next downslope pixels. The reiteration takes several times scanning and completes when growth of accumulation reaches to the last outlet of area. Again, this function is a focal function utilized with reiteration to go on growing the field of accumulation on previous iteration. This slide depicts an enlarged portion of the flow accumulation raster. Pointer on a high count cell reports the aerial accumulation figure in Z window along the lower frame. This is the value which is the spread arrived by count of the uphill cells multiplied by the unit cell dimension, that is in our case 75 meter into 75 meter. As this figure is higher than 1 million square meter, if we supply a rough estimate of more than 1 million square meter as a size to a catchment deriving algorithm and pointing to this high accumulation point, the algorithm will with all certainty return a catchment to this point. This slide is to derive a channel network from an accumulation raster. The fineness of the channel network will depend on minimum segment length we provide to the algorithm. Here we have supplied 10 as a count of the cell, got accumulation to the channel tracer. The derived map channel network will help in tracing the location at the time of running the interactive algorithm, which will trace the boundary of the catchment coarseness or fineness of channel density depending on the provided number to minimum segment length. The shown pattern of a channel network is a typical trellis pattern indicating that the ground is founded by metamorphic rocks having gliding planes, that is a cystosity or nisosity. Now this is the time to invoke the upslope area interactive tool, which is available at a shown menu path and the filling of the forms as shown in the slide at tag 2. Before okaying the tool, the plot over the displayed device is adjusted so that the point can interactively put in for catchment tracing. Tap the arrow marked action button at tag 1. Arrange the stack of layers, first DEM, Second, channel network. Third, the blank white screen generated for upslope area, and make the top layer of view stack 65% transparent so that the upslope area forms the topmost layer for accepting interactive point in enlarged view. Plot the stack, zoom in and indicate the point at a channel network by arrow marked action tool. A click outside or a deviation from the channel network will have a small catchment only. So meticulously point on the channel itself. This is how to pinpoint a location on a channel network in a zoomed in window. You have freedom to point more points on separate channels. Once the point is indicated on the channel network, the algorithm go on tracing the catchment on interactive display device till closure of the action tool. Close the tracing. The output needs to be vectorized to know the aerial and geometry specific informations. Vectorization is an automated exercise with the GIS, so it is utilized to vectorize the catchment from obtained raster. Extract the polygon from unwanted outer universal or other polygons for other catchments if traced. This is the view stack of a catchment and clipped contours in the area. Geometry related attributes become easier to populate if layer is a projected, vectorized or a digitized layer. So area, perimeter, coordinates, etc. can easily be tool calculated in attributes. Tool interactively works with the Cartesian space of a plot over geometries. The derived catchments and its vector conversion is open for overplotted compositions. Here the OSM layers are shown in overplotted combination. I would like to attract your focus on the natural map. See the changing width with which the channel network is shown in the cutout. Again, this is a feature of a quantum GIS to symbolize features in close to realistic manner. This is another set of augmentation shown on this slide. There may be other possibilities also. So within catchments, different type of combinations and different themes can be shown.